Hey guys, so I'm getting ready to go over example 2 from lesson 15. The question says, after taking a cooking class, you decide to try out your new cooking skills by preparing a meal for your family. You have chosen a recipe that uses gourmet mushrooms as the main ingredient. Using the graph below, we're going to complete the table of values and answer the following questions. So I'm looking at the graph and I'm looking at the table. As I'm looking at the graph, I see that we're looking at the gourmet mushroom mix. That's our title. And then I see down here below where my x-axis is, they have labeled this x-axis as the weight of mushrooms in pounds. And then along the y-axis, it's my vertical axis, I notice that it says the cost in dollars. Okay, so we're looking at the relationship between the weight of mushrooms to their cost in dollars. And the weight of mushrooms is in pounds. Okay, so I want to be able to use this information that's in the graph to help me finish filling out the table. So I see that we're missing the cost of 1 pound. So if I find where 1 pound is on my graph and I go up to look at the cost, I see that on the line, that point is 1/8. So what that tells me is that 1 pound of mushrooms would be $8. So I'm going to go ahead and fill that in my table. Now, the second data point that's missing is the weight in pounds. So I see that the cost is $16. So I can go up my y-axis to $16 and I can go across until we meet that point on our line, and that data set is 216. So that means that $16 worth of mushrooms, well, that's 2 pounds. So I'm going to place that into my chart. Okay, great. Now I'm going to answer the questions for the table and graph. Is this relationship proportional? How do you know from examining the graph? Well, what I know from graphs of proportional relationships is that two things must be met. First, the quantities, the pairs of quantities have to form a straight line. The second thing that I know is that that straight line has to go through the origin, that point 0, 0. So as I'm looking at this graph, does it meet both expectations, both requirements? Yes, my pairs of quantities form a straight line going across my graph, and it goes through the point 0, 0, our origin. So is this relationship proportional? Yes. How do I know? The relationship is proportional because the pairs of quantities form a straight line that passes through the origin. Okay, letter B. What is the unit rate for the cost per pound? So on a graph, to find the unit rate, we're trying to find when our x value is equal to 1. So when 1 pound, the cost of what 1 pound of mushrooms would be, well, that's 1, 8 is the data point. So the unit rate, the cost per pound, is that 1 pound of mushrooms costs $8. So each pound or 1 pound costs $8. And maybe I can be more specific. We'll put each pound of mushroom costs $8. Now it's asking us to write an equation to model this data. Well, I know that an equation for a proportional relationship, that generic equation is y is equal to k times x. So if I wanted to create an equation that matches the context of this problem, then I have to think about, well, what is y and what is x in this problem? Well, y represents our dependent variable, and in this case, that's the costs of in dollars, the costs of the mushrooms. The k represents our constant of proportionality or our unit rate, and that x represents our independent variable, which is the weight of the mushrooms. So I can write this out first as a verbal expression. So what I can say is the cost of mushrooms is equal to $8, which is our constant of proportionality, times the weight of the mushrooms. Now, writing it out as a verbal expression helps me because now I can go back and I can make this into an algebraic expression by replacing our dependent variable and independent variable with a letter. So for cost of mushrooms, I'm going to replace that with the letter C. 8 is our constant of proportionality. And for weight of mushrooms, I'm going to replace that with W. So my equation is C is equal to 8 times W, where C represents the cost of mushrooms and W represents the weight of the mushrooms. Letter D says, what ordered pair represents the unit rate and what does it mean? Well, we already found that unit rate. That unit rate from the problem was this quantities 1 and 8. And so what does that ordered pair represent? 1, 8. Well, it represents that 1 pound of mushrooms is $8. It costs $8. So 1 pound of mushrooms, maybe instead of is, we put costs. $8. That's what this ordered pair represents. Now let's look at E. What does the ordered pair 216 mean in the context of the problem? Well, remember that this is written as an X, Y. That's what our ordered pairs are written as. Remember that X is our independent variable and Y is our dependent variable. So if we're talking about 2 as our X, then that represents the weight of the mushrooms in pounds. So this must mean 2 pounds of mushrooms. And now this 16 is where the Y is in as an ordered pair, and that is our dependent variable. And on our chart, on our graph, that represents the costs in dollars. So that means that 2 pounds of mushrooms costs $16. If you could spend $10 on mushrooms, how many pounds could you buy? Now, in order to solve this problem, I need to go ahead and use that equation that we found, that C is equal to 8W. This equation represents the relationship between the weight of the mushrooms and the cost of the mushrooms. So I can use this equation to help me solve any problem regarding that relationship. So I'm going to rewrite that equation. C is equal to 8 times W. Now in the problem it says if you could spend $10 on mushrooms, how many pounds could you buy? So in this problem, I'm looking for pounds. So I'm looking for the weight. I'm looking for the W. So that must mean that this 10 represents the cost of the mushrooms, my C. So I can just go ahead and replace $10 in our equation for the value of C. So let's do that. 10 is equal to 8W. Now, I want to figure out what this W is, so I want to get this alone. But right now, it's attached to this 8, and it's bonded to this 8 by multiplication. The 8 is being multiplied to the W. So if I want to break this bond in order to get this W by itself, I'm going to have to do the opposite operation. The opposite operation of multiplication is division. So I would have to divide by 8 in order to eliminate the 8 from the right side of the equation and be left with just the W. However, in order to stay balanced, if I divide by 8 on the right side of my equation, I must do the same on the left side of my equation. So now I'm left with 10 over 8. So we have W is equal to 10 over 8. Well, that can be simplified. So 8 goes into 10 one time, and that leaves us with 2/8 left over. Well, even 2/8 can be simplified. 2/8 represents 1/4. So all we've done is rewritten 10/8 as an equivalent mixed number of 1 and 2/8, and then we rewrote it again as an equivalent mixed number of 1 and 1/4. And so what does this mean? It means that for $10, we can buy 1 and 1/4 pounds of mushrooms. So I'm going to write my smart statement. $10 will buy 1 and 1/4 pounds of mushrooms. All right. Last question. What would be the cost of 30 pounds of mushrooms? Well, once again, I can use that equation. C is equal to 8W to help us define this answer. So in this problem, we're looking for the cost. See, what would the cost be? But they're telling us the weight. It's 30 pounds. So in this situation, we're looking for the C, but we know the W. I can go ahead and replace the value of W with 30. So I'm going to rewrite the equation, replacing W with 30. And so I see in order to find C, I'm going to have to multiply 30 times 8. Well, I know that 8 times 3 makes 24. So if 8 times 3 makes 24, then 8 times 30 is going to make 240. So what does that mean? Well, that means that 30 pounds of mushrooms costs $240. And that's it. Now go ahead and finish your exit ticket.